Today we're going to look at the squeeze theorem, which is a really, really cool theorem that lets us evaluate some limits that we might not otherwise have been able to figure out. Essentially, what we're going to do is figure out something that we can pin our limit or our function that we're trying to find the limit of between. So maybe I know that f of x is always going to be greater than h of x and always going to be less than g of x. If I know something about h of x and g of x, then I can use that to try and find some information about g of x. So if I know that inequality is true, and then I can show that the limit of the smallest function equals the limit of the biggest function, then that forces the middle function to be equal to the same value. The idea of that is that if I said something like 4 is less than or equal to x, less than or equal to 4. Well, the only way you can be less than or equal to 4 and greater than or equal to 4 is only equal to 4. So that's the idea. If I can force my function to fall between two values that I know, then we don't actually have to figure out the limit by hand. We can prove that it exists by using the idea of this inequality. So this is actually a pretty powerful tool that we have when we have a limit that maybe we don't have algebraic tools to do. This is going to be the most useful, as a strategy to come up with on your own when you're working with a trig function, because for sine and cosine, we know for sure that the range is going to be between -1 and +1. So that gives us a place to start. It doesn't have to be that way. If you look at number 10, what they did was they told us that f of x falls between these two values, and they ask us to go ahead and find the limit of the unknown function in the middle. So both of these will apply squeeze theorem. So on number 9, they gave us a picture of the graph, which I think is cool because it helps you visualize what we're doing. So the functions f of x equals x, g of x equals -x, and h of x equals x times the cosine of 50 pi over x on the interval from -1 to +1 are at the right. So the two functions that we're going to eventually squeeze this between, and I'll show you how we choose those, are going to be x and -x. And you can see, physically, the idea of squeezing this function. It's getting smaller and smaller and smaller as we move towards 0, and we're squeezing it down to this single point. So it appears, even though that's an oscillating function, it appears that we're going to be able to say it's approaching 0. But we'll have to determine that by using the squeeze theorem. So what I'm going to do when I want to find the squeeze theorem is I'm going to pick a piece of the function that I know something about. And so in that case, it's just the cosine piece. Because of what I know about the range of cosine, I know that the following statement is definitely true. -1 has to be less than or equal to the cosine of 50 pi over x. And that must be less than or equal to +1 because cosine only goes from -1 to +1. So we know that for sure. But cosine of 50 pi over x is not exactly the function I'm trying to look at. I need that x in there also. So now we're going to use algebra to manipulate this inequality. So the first thing that I will do is multiply everything by x. So now I have -x, my pen died, -x less than or equal to the cosine of 50 pi over x. I'm intentionally leaving myself a little bit of space here, and that's less than or equal to x. That's why we knew that we were going to squeeze it between these two functions, x and -x, okay? Now remember, oops, I forgot my x in the middle. That was the whole point, was to get an x right there. Make sure that you've got that. The whole point of this is to find a limit. And we haven't even gotten to the limit yet. But now that I have the function h of x in the center, now I'm ready to take the limit. And again, limit is an operation, so that means we can do it to both sides just like you would do anything to an equation. So in this case, now I'm going to come through, and the limit I want is the limit as x approaches 0. So I'm going to take the limit as x approaches 0 of negative x. I'm going to take the limit as x approaches 0 of the middle, and I'm going to take the limit as x approaches 0 of the right-hand side. Now, I still don't know what this is going to be, but the limit as x approaches 0 of negative x, you can just substitute in 0 and we get 0. And the limit as x approaches 0 of x on the right, I can substitute in 0 and I just get 0. So here's what I now know. 0 has to be less than or equal to the limit as x approaches 0 of x cosine 50 pi over x, which is the thing we were trying to figure out, and that must be less than or equal to 0. Therefore, the only value that makes sense for the limit in between, we can now say by squeeze theorem, sorry, I switched to cursive all of a sudden. By the squeeze theorem, we know that the limit as x approaches 0 of h of x, since it has a name, I'm going to use it rather than recopying that over again, equals 0. And that is our answer. We didn't have to do any algebra to h of x itself at all. Instead, we pinned it between two things we know and forced this to work out. Let's look at number 10. So number 10 is a little bit different approach. Instead of us figuring out the two functions that it's between, we have some unknown function f of x, but what we do know about f of x is that 1 is less than or equal to f of x is less than or equal to x squared plus 2x plus 2 for all x values. We want to find the limit as x approaches negative 1 of f of x, and we want to justify our answer, which means we need to use a theorem or something like that. So since I know that that's true, and f of x is what we want the limit of, using the squeeze theorem, and this is how this shows up on the AP exam a lot. Using the squeeze theorem, then, we can take the limit in all spots. So I'm going to take the limit as x approaches negative 1 of 1, less than or equal to the limit as x approaches negative 1 of f of x, less than or equal to the limit as x approaches negative 1 of x squared plus 2x plus 2. The hope is that the two outside limits will have the same value. That's our goal. So the limit of a constant is just the constant, so this is equal to 1. The limit of the inside, we still don't know. That's what we're hoping to get some info on here. Less than or equal to, on this side, if I plug this in, I get negative 1 squared, which is 1, minus 2, which is negative 1, plus 2, which is positive 1. So there we have it. So now we can say, again, it asked us to justify, so we got to make sure that we do. We can say the limit as x approaches negative 1 of f of x equals 1 by the squeeze theorem. Okay? Number 11 and number 12 are very similar to number 10 and number 9, so I'm going to leave those as an exercise for you to kind of check your own understanding. So work out number 11 and 12 and then go to the PDF document to see if you did them correctly. There's not, I think, any specific practice problems on this in your homework packet, so these are your two chances to kind of check your own understanding and see what questions you have. So I'm going to leave those for you to do on your own.